Energy. Do we need it? Where would we be without it? As you're probably aware, energy is necessary to heat, cool, or light our homes, schools, factories, offices, right? Energy also moves all the vehicles, planes, ships, and trains, right? But also, energy uh, moves our bodies, insects, phones, trees, and most importantly for you guys is the internet, right? Now we can't understand the world we live in without understanding the energy. Here in the United States, in this country, we are the most intense society in the human history. You guys are living at times where energy is at its peak ever. So there was energy wasn't used as much before in the history as it is used right now. Now what will happen if there is no energy? Well, you know what happens to your lives, right? When the power goes out, well, you guys are bored, right? Or even worse, if the internet would go out, then you would be all in trouble, right? Now, saving, producing, and using energy wisely will be crucial to our future. So that's a little intro about energy. So let's get started with your requirements. Requirement 1A. 1A is where you need to find an article on the use or conservation of the energy. Now, where would you find that article? Well, it's up to you. If you have magazines at home, and you're more than welcome to use it, read it, fulfill the requirement. If you're like me, I don't have the article about conserving an energy. I'll go on Google. I just type Google conserving energy and article, and the first one down was from NPR. And the article from NPR is the one I choose to read. You can use the same one, you can use different one, it's completely up to you. So now when you read that article, write down what your interested was, what interests you, what ideas it addressed, and if you didn't understand something that article was talking about, write it down. And it's okay, you know. Now I don't need any essay from you guys, just few sentences, 1-2 sentences on each subject. If you want to write more, go for it, absolutely, I would love to read it, but I know how hard it is sometimes, so 1-2 sentences is sufficient. I just want to make sure you guys understood the subject. At this time, you guys should pause the video, do your requirement 1A, and then resume. And the reason why 1B requirement is to be done after you guys fulfill all the other requirements 2 through 8. So go ahead, pause the video, do your requirement, then come back, unpause, I'll be here, and we'll just get started on the requirement 2. Okay, we're back. Requirement number 2 wants you to show you understand energy forms and conversions by doing the following. A. Explain how 3 of the following devices use energy and explain their energy conversions: toaster, greenhouse, light bulb, ball drill, nuclear reactor, or sweet lodge. So this is 1A. I'm sure you guys are all very curious, how does the toaster work? So as you already know, the toaster operates by electricity. So unlike the regular conventional oven, where you have the option of using a gas or electric, toaster operates on electricity only. And he also, as you probably On a side note, as you probably notice, it has a short cord, and that short cord is for safety. So how does the toaster work? Well, when you press the handle and lower your bread slices, a wedge in the toaster forces two contacts together. These are the ones that connect the power supply nichrome wires that have electricity around plates called mica sheets. Like any wires in your house, nichrome wires conduct electricity. However, most wires made of metal convey electricity way better compared to nichrome. Basically, electricity will pass through a wire easy, which further allows them to be used in various appliances. With nichrome wires, however, electricity isn't delivered as efficiently as is by copper. That implies that all the energy from the power cord cannot be transferred down to nichrome wire. So instead, this energy is converted into heat. This is why you will realize that the same kind of heating elements are used together with fans in household hair dryers. Heated up nichrome wires will heat up anything around them, including the bread slices. The amount of time the bread slices spend close to the wires determines to what level they will be toasted. And you will leave the slices in for too long, they will turn completely black, and I'm sure you have done it, and they might start smoking or even catch on fire. That said, if you're using one of the best modern toasters that has been designed with safety features that will allow it to stop on their own, ensure it does not happen. When your slices have been sufficiently toasted, simply press the high lift level. This will raise the slices high enough to retrieve them without burning your fingers. So this is pretty much how does the toaster work. So next thing we're gonna cover is a light bulb. So what is a light bulb? Light bulb is a simple apparatus that converts electric energy into light. So we're changing one form of energy into the other. And the law of the conservation of energy says that the energy can neither be created nor destroyed. It simply changes form. So we're changing the form of energy from electricity into light. Now, what is the light bulb made out of? The light bulb is made out of positive and negative terminals put inside the glass with the tungsten filament that joins the two. Now, when electricity is supplied to the terminals, the flow of electrons heats up the thin filament in between. The electrodes continue to bang against the filament until it heats up to the point that it begins to glow, and obviously that happens really quick. Now, what does make the light bulb glow? The filament that's inside the clear glass or milky glass, depends on the style of the light bulb you have. Protects the light bulb from overheating. The glass protects the light bulb from overheating, and the air inside the glass is actually a small amount of inert gas that helps prevent the filament from becoming too hot. And then when the light bulb has fused, it means that the thin coil inside has snapped, and therefore the electricity cannot flow completely through the circuit. And that is true also for the new style of the light bulbs. Next, we're gonna cover greenhouses. So I'm pretty sure most of you seen the greenhouses. You drive by sometimes, you see them by the farms. Those are those buildings that are covered either with plastic or with glass roofs. And the way it works is that the walls or the ceiling heats up because of the solar, the sun hits the roofs, warms up the plants, soils, and other things inside the building. The air warmed by the heat from the interior surfaces is retained in the building by the roof and walls. The structure range obviously in size from small sheds to the very large buildings. There are few types of greenhouses. There are cold houses and cold frames. Helps start spring crops a few weeks early and extend fall growing season. Cool houses are warmer than above house, protects the frost in sensitive plants like geraniums. Warm houses, orchids and ferns can grow over the winter, and the hot houses are the house for tropical plants all around 60 Fahrenheit or higher. So if you go, for example, to Detroit Zoo, you might see hot houses where the temperature stays same throughout the whole year. And this concludes the greenhouse. Okay, requirement to be construct a system that makes at least two energy conversions and explain this to your counselor. So there are different options you guys have for this requirement. It's completely up to you how would you want to do it. One option you guys could do is create a little greenhouse. Uh, the greenhouse can be something simple. Just put some soil, few seeds inside the cup, and cover the cup with the foil. And that's how you can create a little greenhouse that will convert light energy. They will convert into light energy into heat, and if you want, you can grow plants and stuff, and then you create a photosynthesis, and it's gonna go farther. But for that, you can just explain to me, hey, I did the greenhouse, and this is how I did it. That's how I went about it. So it's up to you. You can use different form. This is just one example I have for you. Okay. For requirement 3, I have the little chart you'll see in a second, and that chart will explain to you the energy efficiency and example of the situation where energy moves through a system to produce a useful result. And what you need to do is identify the parts of the system, name the system, identify the useful outcomes, and identify the energy losses of the system. So the chart that you will see shortly will explain all those aspects. Okay, requirement 4 was prereq for this class. You guys were gonna conduct a 14-day log that records what you and your family did to reduce the energy. So for 4A was include and discuss the list the types of energy used at your home, such as electricity, wood, oil, and natural gas, and tell how each is delivered and measured at the current cost. Or you could record the transportation fuel used, miles driven per gallon, and trips used for using your family car or another vehicle. And then for 4B, you will describe the ways you and your family can use energy resources more wisely. In preparing discussion, consider the energy required for things you would do to use on a daily basis. And then you had the requirement 4B, where you describe ways you and your family can use energy resources more wisely. In preparing your discussion, consider the energy required for the things you do and use on a daily basis, such as cooking, showering, using lights, driving, watching TV, and so on. Explain how you can change your energy use, reuse, and recycle. So I think that's pretty self-explanatory too. And I'm sure you have the charts. If not, I can email you something on that. So for requirement 5, it says in a notebook, identified and describe 5 examples of energy waste in your school or community. Suggest in each case possible ways to reduce this waste. Describe the idea of trade offs in energy use. In your response, do the following: explain how the changes you suggest would lower the cost, reduce pollution, or otherwise improve community. Explain what changes to routine habits on or convenience are necessary to reduce the energy waste. Tell why people might resist the changes you suggest. So it's up to you what you would put for number 5. Some of the things might be turning the computers off, for example, and the office buildings, or turn the lights off. Maybe add a sensor switches on the lights, so the lights get triggered by motion. There are just a couple examples. I'm sure you guys can be creative and come up with some other ideas that could do. Now, one thing that what on the B portion of that, where you explain the changes, what changes to routines and why people might resist the changes you suggest. So from my personal experience, people tend to resist any change, right? So anytime that causes people inconvenience or something they are not used to do it. That's gonna create resistance. Or anytime you do anything different, suggest anything different to people, they'll resist because it's gonna put them out of the comfort zone they are in. But again, you can be creative and give me a few different ideas of your own. Requirement number 6. Prepare pie charts showing the following information and explain to your counselor the important ideas each chart reveals. Tell where you got your information. Explain how cost affects the use of non-renewable energy resource and makes alternatives practical. So I'm gonna show you the charts at the end of requirement 6. Now for 6.8, the energy resources that supply the U.S. With most of its energy. So the United States receives approximately 84% of its energy from fossil fuels. The energy is used for transport, industry, and domestic use. Requirement 6b, the share of energy resources used by the United States that comes from different countries or other countries. Approximately half of the petroleum products comes from the imports. We are the third largest producer of oil in the world. 6c, the portion of energy resources used by homes, businesses, industry, and transportation. Industrial users consume about 37%, personal and commercial transportation about 20%, residential heating, lighting, and appliances use 11, and commercial uses and about 5% of the total. The other 27% of the world's energy is lost in energy transmissions and generation, as the efficiency of a typical existing power plant is around 38%. And then 6D, the fuels used to generate America's electricity. Many energy sources provide the fuel is necessary to generate electricity. The combination of energy sources used in referred to as a generation or fuel mix. More than half of the nation's electricity supply is generated from coal. Nuclear fuel produces almost 20% of the supply. Natural gas supplies nearly 16%. And 6E, the world's known and estimated primary energy source reserves. So most of the world's energy resources are from the sun rays hitting Earth. Some of the energy has been preserved as fossil energy. Some is directly or indirectly usable through wind, hydro, or wave power. The solar constant is the amount of incoming solar electromagnetic radiation per unit area measured on the outer surface of Earth atmosphere. And now I'm going to show you all the charts. Requirement number 7. Tell what is being done to make 5 of the following energy systems produce more usable energy. In your explanation, describe the energy costs, environmental impacts, and safety concerns. So I'm gonna save you guys from listening to me talking, and I'll show you actually that on a chart, and you guys can read and understand that a little bit, hopefully a little bit better. Okay, at this point you can go back to your requirement 1B, which states after you have completed the requirements 2 through 8, which we just did, revisit the article you have found for requirement 1A, explain what you have learned in completing the requirements that helps you better understand the article. So you may want to pause the video, go back to 1B, get it done, and after that, the only one thing that's left is for you. It's like most of the merit badges is you have to find out for requirement 8, find out what opportunities are available for career in energy. Choose one position that interests you and describe the education and training requirement. So I guess unlike a lot of them, a lot of the merit badges where you have to find 3 careers, this one you only need one. So that's pretty good. Okay, I guess that's it for this class. I hope you guys had good time, learned something new. If you didn't understand something or have questions, please feel free to email me. I'll respond shortly. Otherwise, like I mentioned at the beginning, please send me the your worksheet or simple question and answer sheet, and I'll send that to the counselor, and you guys will be able to receive your merit badge. If you're not sure how to receive the merit badge from the black plug, I think it's called, let me know. I'll send you the instructional video, or actually it's not a video. I'll send you the uh, directions how to do it. Once again, I hope you enjoyed it. Thank you for listening. Thank you for being a scout, and scout on. Thank you. Bye.